Alright, hello, welcome to a new video. We're gonna do delete node and BST. Anyways, let's get started sorting out the problem. So given a root node reference of a binary search tree and a key, delete the node with the given key in the binary search tree. Return the root node reference, possibly updated, of the binary search tree. Okay, basically the deletion can be divided into two stages: search for a node to remove, and then if a node is not found, then delete node. Okay, so we're given a root of BT, and then maybe node to delete. I think maybe like, maybe it's like node.val, maybe? I don't know. We'll see. Oh, it is a binary search tree, yeah. And then we're supposed to output the root of BT, but with node deleted, right? So to note, then when delete node must fill in the hole. We can fill in the hole with like left, right, or none, I guess, or like null. Yeah, that's a good thing to note. Like, it just makes sense, right? That does make sense. Yeah. Yeah, that does make sense. Okay, and so after that, I think those are all the notes that I can have. And then I guess to ask some questions like what is the min size of BST? I don't think the value actually matters. So the size can be 0. I don't think the value matters. Then it's good to note that I'm pretty sure in a binary search tree that it's given that every node is unique because it's a binary search tree, right? So it makes sense, right? So I think that's fine. But I guess you could ask that question too. So let's go through some examples, I guess. Kind of showcase how I do understand it. So I want to write. I'll just do like 10. I guess it's like 30. This is like 40. This is like 33, and it's like 5 5 3 7 7. Okay, they like this. Pretty small, actually. Can I make it bigger? Oh, I can't. Wait, this thing is so good. What the hell? Wait, this app is like amazing. Anyway, so let's go make arrows. So boom, boom, boom. Wow, this is amazing. It doesn't look that good, but like it's just an amazing way it can do pretty fast, and like the way it looks. It looks pretty good, like pretty neat. Anyways, so let's say we have this, for example, and then I'm gonna guess. Actually, let me look at the other examples. Yeah, okay, so the key is like the target value, basically. Let's say our target val is equal to, I guess, like 5, right? If our target value is 5. All right, this seems, actually, let's make an easy case first. So let's say it's like 7. So target value is 7. We know that 7 is less than 10, so we go left. We know that 7 is more than 5, so we go right. Then we see the 7. We see the 7, right? So we're just going to remove it, right? Pretty simple. Just remove it, right? And that's basically it. So now 5 points to null, I guess. But that's too easy. Let's do it in a case where like target value is 5. Okay, so we're at 5. I mean, we know the value is 5 that we want to find. 5 is less than 10, so we go left. So then we found 5, right? We're at 5, exactly 5. So now we just gotta delete 5, right? That's all we gotta do. Boom. But then we're missing all the other things, 3 and 7, right? So how are we gonna solve this? Well, in their example, what they did, or like if I were to do this like as an interview, I would ask a question. So like, how would you want me to remove X? I'll write that. How would you want me to remove the node with children? Right? I think that's a good question. I mean, there's multiple ways you can do this. I don't think it really matters as much, because if you remove this 5, then you could say that 5 gets replaced with 7, right? And it'll make sense in such that the case is that this 7 can have a left of 3, right? Like, it just makes sense. Or this 3 can have a right of 7, because it makes sense, because 7 is more than 3, right? So it makes sense there. And then 7 is more than 3. So 7's left is 3. So it doesn't really matter. But I guess it matters in the case and such that, let's say, right, it was 5. So we can, so I guess to match, if both children exist, do either, right? But what if one children doesn't exist, right? But let's check both. Let's say it's like this. Then it's gotta be that like 3 has to be the one that replaces 5, right? If yeah, it's gotta be the case. So if left exists, replace. If right exists, replace. Right, but if not, right? Like if not, then what happens? If not, then what happens? So let's say if it was like just like 5, right? If none exists, then I guess we can just replace with null. If none, replace with null. Right, so this is the basic stuffs. But then one case arises where when we want to replace it, right? Where we want to replace it, like how are we gonna say that like 7 is a replacement for 5, right? How are we gonna say that? Well, we need a previous pointer. And to do that, we just need to say prev, right? Prev. So prev is equal to 10, right? And then once we do find it, we gotta say that like we gotta say that, so we do the operations, we do like, okay, so 5, we gotta do like, okay, 7, no, we gotta say that 7 points to 3. 7's left points to 3, right? 7's left points to 3, and now 10's left points to, or previous is left points to 7 now. So there's a lot of loopholes. I mean, it's not a lot of loopholes. There's like a lot of logic going on. So prev, and we have to also determine like where does prev point. So how to know where prev points, right? I think we need to say is left. We say is left, because when we do DFS, right? When we do DFS, we're gonna take in node. Take in node is left and prev, right? Or maybe prev can be a global variable. I don't know. Prev question mark. I don't know. But is left is gonna be good because in the code we can say if is left is true, then prev points to then prev will point its left to whatever just replaced it. So yeah. Yeah, I think that's how it's gonna go. Let's keep that in mind. I'm pretty sure that's pretty much it on the matching. But now what I'm gonna do is I'm just going to let the matcha hit. What I'm gonna do is I'm going to make some pseudocode, right? So let's just, I'm pretty sure we can make prev a global variable. I think so. Like, I don't think it should matter because it shouldn't really matter if it's a global variable because we're only going through like one iteration, but we're just using recursion to do that. So it's fine. It's like a while loop, like while left less than right. But we're just doing a recursion instead of like binary search through a list. So yeah, we're only looking for like one answer which is guaranteed. So so DFS. No, we actually gotta initiate our global variable. So prev is equal to none for now. And then we gotta do DFS with node and is left. Okay, so yeah, so this makes sense. So now first thing we want to do is like we gotta first off detect if not node. Node, then return none. Is that what they want us to do? If it is oh, we don't really return anything. Yeah, we don't really want to return anything, but so if we're not node, then just return. And then where was I? Yes, so if not node, return none, and then we gotta do binary search, right? So first we gotta do the case where binary search. First we gotta do the case and such that find target and don't find target. So I think it's better off to code the don't find target part. So if you don't find target, so if target less than no.val, then DFS no.left and say is left is true. And then else targets more than no.val. No.val. Then do DFS on the no.right and say is right is left is false. Right? But then we need to do the case where we find the target. Okay? Finding target's the hardest part. So because there's a lot of logic that goes with it as we went through it. Yeah, we also have previous. Then I guess we say that maybe we do. I don't think it really matters though because it goes one way all the time. But we'll see. So I say previous is equal to node. And then we're just gonna say that non-local previous. Previous equals to, I think this should work, or unless we can just put previous into the thing, right? So if we do find the target, so let's say we find this 5, right? We find 5. So in the case in such that if target is equal to no.val, right? What do we do? What do we do? So if target is equal to no.val, cool, we gotta remove it, right? But how do we remove it? We gotta check. I think it's safe. We can say we can do either way, but I guess we can say like, so if no dot left exists, then replace. Then we gotta say that node dot left we're gonna say that node dot right, node dot left. Wait, that's a weird case. Wait, I don't think I solved it, because what if node dot left has like, right? How about, what if it has this? Ooh, that's harsh. This is so harsh. Yeah, what if that's the case? I actually don't know the solution. So what if no dot left, it does exist, and then yeah, what if it's like this? We say that maybe do I need another helper function? Do I need another helper function? Do I need another helper function? That's the question. I don't know. But what if I also had like like 6 and then like 8, right? What if I had it like that? I would say that 7. Yeah, I would need to go all the way left. Because I guess Do I need a helper function? Maybe I do need a helper function. So I guess I can say we need helper functions. So these will return the last node. So returns last nodes of subtree to put left and right on. So in this case, if I were to do like the right side, right? So if I say that remove 5, right? Now 7. Oops. Now 7 is like the new 5. I have to put like this, right? I have to put like that, you know? So I think I have to say like, okay, so get most left. So I have to say, taking a node. So I have to say that, I have to be like, so while node dot left like while node dot left node is equal to node dot left, right? So in this case we're at 7. We gave it 7. We go node dot left is true, so go left. So now the node is equal to node dot left, which is 6. And then when we're at 6, ignore this arrow. We're at 6, and now we're like, well, node dot left, that's false, so we don't do anything. So then we just return node. And now, I guess in this case, so if target, I guess we could say if node right exists, then replace. So node dot right. Okay, hold up. I gotta look at it first. This. Okay, so node. Right. So if node dot right exists, they replace. So node dot right. Okay, so I gotta say this. So right most left is equal to get most left of node dot right. And then we should have 6. So then we have to say that right's most left dot left is equal to node dot left. Yeah. Yeah, that makes sense. And so what this does is that this whole 3 is pointing like this, right? Right. And then what happens? Is that the 5 is still there, right? So what do we do with that 5? Well, we kind of remove it, right? So then we gotta say that if it's true, and such that so if it's the case, if is left, then previous dot left is equal to no dot left. No dot right. Oops. And else previous dot right is equal to no dot left. Right? Just the logic. And then this can, yeah, then we need to do the right and the left. No, we need to do the right. No, we need to do the left. So the left is basically just like the same thing, but so no dot left exists, replace with left's most right, and then you get the deal. So left's most right, and then it's right. We get most right. Get most right, and we give it no dot left, and then we should get its most left, and then if is left, then yeah. Right, so this makes sense, and we just get say that this is another helper function as well. This is kind of the code base. I'm just gonna stop. This makes sense already. To me, like this works. So yeah, I'm just gonna copy paste this plan in LeetCode to see what's up. So delete node. Okay. So first things first is I want to set a previous. So previous is equal to none. Then I want to just define our functions already. So define DFS with node and is left boolean, and then we have get most left with the node. Then we have get most right with the node. Let's code our DFS first. All right, so we're gonna have we're gonna reference non-local previous, and then we're gonna say, so if we hit null, then just return. Not node, then just return. Now, so if target or if key is equal to if key is equal to that val, then do something, right? But if not, I like this case where it's just this is complicated. So we gotta see. So if node dot right exists, I say left. So if node dot left exists, then we gotta do all this code. So if node dot left exists, then yeah, if node dot left exists, then we gotta say its most right is equal to node dot no is equal to all this, right? So we gotta say most right is equal to get most right, and we're going to give it no dot left, right? And from there we say that most right dot right is equal to node dot right. So we're basically doing this. We're basically doing this. Hold up. Basically doing this. Why does it look so sloppy? We're doing this basically. So we say that most right is equal to get most right of node dot left. And then we say that the most right dot right is equal to node dot right, which is just what we brought it down to. Right, so that's basically it. And then we need to replace the 5. So we say that previous, we want to know if it's pointing left or right first. Alright, no, so if is left, then we have to say that previous dot left is equal to node dot left. Else previous dot right is equal to node dot right. I mean, I guess we can do this like, yeah, I think this is fine. I think I'm just rewriting code, but like it just makes sense to me. So elif am I rewriting code? I don't know if I'm rewriting code. So else if elif node dot right, then elif node dot right, then we gotta say that, oops. Then we gotta say that, oops. We gotta say that, dude, why is it, okay. We gotta say that it's most left. So most left is equal to get most left. Give it node dot right. I'm gonna say that it's most left dot left is equal to node dot left. Right, because this is node dot left, this 3 is node dot left. And then we gotta say if is left, then prev dot left is equal to node dot right. No, I think this is it. Wait. Yeah. And then else, then prev dot right is equal to node dot right. Because we don't know if it's pointing this way. Yeah, this way or whatever way. I don't know. Yeah, we don't know where the previous is pointing at because it could be like here. I don't know. Does that make sense? I think that makes sense. Like, I think that logic makes sense. Yeah, because we can't just say like prev dot previous dot next. We can't say that. So, right? But if if neither of that is the case, then we just say that what do I say? So if they're null, basically. I mean, if they're null, doesn't really matter, right? Well, I know it does matter, but like, so 5, then we gotta replace it with null. Then we say that previous if is left then previous dot left equals to none, and then else, then previous dot right points to none. Right? That makes sense, right? And so, yeah, that makes total sense. So now what we gotta do is we got to code the case where we don't find a target. It's pretty easy. So if target or if key is less than no.val, so else if key is less than val, then what we gotta do is we have to go left. So ifs no.left, and then is left is true. But then we gotta say that previous is equal to node. And then else we gotta say previous is equal to node still. Then DFS no.right. Then is left, but let's say like not. Can I say like this? Oh no, we gotta say true. True. Then false. Right? And so yeah, that makes sense. Alright, so now this makes sense. Now we gotta code these parts out. So while node node dot left is true, then we say that node is equal to node dot left. Just keep on going, and then we return node once we're done. And same case here. So while node dot right is true, then node is equal to node dot right. It's not the case, then return node. Yeah, this makes sense. So so this is done. Now all we gotta do is we got to wait, I think I can just say this. Right, this makes sense. Oh wait, no, I can't say that because okay. I can't say that because what if it hits this, right? So what can I say here? Else if I think it's fine. Return node. And then what I gotta do is I gotta call DFS. So call DFS with root and I guess it doesn't really matter what we say is left is. Does it really matter if what is left is at the beginning? Because if it's the first node, I don't think it matters, right? But let's just test that out. So oh, I can go up or down. Wait, this is crazy. This is so crazy. Oh, wow, this is so crazy. Dude, this thing's amazing. All right, so what if it was like just like 1, right? If our target is 1, so we give it the root. We give it the root and the value of 1. So it says that previous is equal to none. Okay. And so if no dot left, so no, if key is equal to no val, right? That's true. Then what happens is that we go through here. I mean, we don't go through any of these. We go through this one else, right? So I don't think it matters. Else is left. So if it is left, then because then this would have none, right, by default, right? So it says that okay, so it says that is left. If is left is true, then previous dot left is equal to none. So none is equal to none. I think that's fine, right? But none doesn't have dude, what if it is none? Oh my god. Wait, okay, so if is left, previous is equal to previous is none, so none doesn't have none doesn't have a left or right. So and previous else elif is left, not is left, and previous do this. In the case is where that else else where it is previous where it's not previous. So else if not previous. What do I say? So if it's not previous, then node. Do I say that node is equal to none? I think that works. Because this node is equal to none now. Right? Because it doesn't have a previous. So run. What do you mean like expects like a Wait, oh, I'm not okay. It's elif. Oh, root and is left. Say true. Fuck. Can I just say like previous is equal to? You have to make it like a, I don't know. Maybe like node. Give it node. Oops. Still wrong. It has to do with this. It has to do with this, right? Whoa. Oh wait, no. Let's return roots. Wait, I'm so stupid. Wow, okay. Okay, so submit. Wrong answer on 0, 0. Okay, so else if, okay. So if node is equal to, doesn't have the dot left, so um if left and prev should be none in this case. So then elif not prev, and the current node is equal to none. I gotta see. Let's see what this runs. Okay, so is that right? No, okay, so it goes through here. This says hello. Node is equal to none. Why doesn't it go through? Say no that Val? Did you go to none? I don't know. What want me to do? I don't get it. So how to delete node in Python? That's what I'm doing. What? Wait, gotta pause. Oh my god, I just realized. So basically, else return none, right? And then I realized that just call this initially with the root and true and none. And so when we initially call it, it's gonna go through depth for search. Once all that is done, and this does nothing, we can just return the node from the original call, which is the root. And then yeah, submit. Oh my god. Okay, so know that none type has they go through here. Should it just be like if not no dot left? Let's do this. I'm not sure why that logic is true. I don't get it. I hate debugging this. Okay. So okay, so then why does it go through? Why does it do that for search? There shouldn't be that for search. So oh, okay, I see. So if no dot left. Oh, say and prev. Okay, still wrong. Okay. Okay, so what if this is the case? I didn't account for this. So if this is the case, it's like this, right? And then it is left. So if if not rev, then I guess rev is equal to node. No, we can't say that prev is equal to node. Can we? Because we say is if left and prev dot left is equal to node dot left. It'd be the same thing. Hmm. Oh, we gotta say that prev is equal to. Then we gotta say that like. Hmm. Then I guess we can say that like most dot right is equal to this 4. So we can say so if prev, then do this. Else do this. We say that node is equal to node dot left. Okay, that makes sense. And it should pass. Yeah, okay, then we gotta do this, the same thing. Then we gotta say, so if prev exists, then do this, but if not, then we can just say else. Then we can just say that the node is equal to node dot right. Run, submit. Oh my god, wrong answer. So 1 through hello. Oh my god, it looks like this. Okay, what do I do here? Okay, so node dot left. Oh, because of this. Oopsie. Okay, runs. God damn, that was so much time. That was like an hour. Wow. That was a waste of time. Anyways, so yeah.